guys, in this tutorial we will go over two standard charts that you may want to consider to visualize your numerical data. Before we start, please, if you find value out of this video, like and subscribe. Also, the link to the code that is shown in this tutorial can be found in the description box. That being said, let's get to it. So this is, or I'm going to use the same data file that I used in some previous tutorial, and then this is the data file called credit risk dataset. And as I mentioned before, this data file contains information associated to loan applications. So we have some basic demographic information on the applicants, and then we also have some information associated to the loan. Okay, in terms of, the loan grade, the loan amount, the interest, and so on. Okay, so also, from the machine learning perspective, the loan status is the target variable, right? So 1 means that the loan has defaulted, 0 means that the loan hasn't default. Okay, so if you were to build a classification model, loan status will be the target variable, and then you will use the other features as potential input variables. Okay, but that is not the purpose of this tutorial. So in this tutorial, we will go over again two charts that you may want to consider to visualize your numerical data. So let's assume that we are interested, for example, in loan amount. Okay, so let's say we're interested in having a better understanding about those numbers. Okay, typically, again, when you want to have an understanding about numerical data, the very first thing that you do is you create what is called the file number summary. So file number summary. Okay, so basically that will give us a very quick overview of the distribution of those numbers. So then in this case, again, given that we're interested on the loan amount, so then we will do the following. So then the data frame is called df. So I start with df and then loan amount, and then I will use that describe. So then that command basically it reports the following. So we see how many values we have stored there, the average, the standard deviation, the minimum, the first quartile, the median, the third quartile, and the maximum. So that right there, again, just in one quick view, we start having a better understanding about the distribution of those numbers. However, just looking at numbers by themselves, I mean, it could be a little bit tricky to make sense out of them. So then that's where charts basically are more useful than looking at a pile of numbers. So then when it comes to visualizing numerical data, by far the most common, or at least one of the most common charts that you may consider to visualize your numerical data is called a histogram. So let's create a histogram here. Okay, the commands to create a histogram is very simple. So then I notice that I already load Matplotlib. So let's do the following. So fake x equals plot to plot. That's typically what I like to use. And then here we say creating the histogram. So what this line is doing is just creating, the dimensions for the figure that I'm going to create. Okay, so then here I just start with plt, and then the command that you need to keep in mind to create a histogram is called his. Okay, it's his, and then df long amount, and let's start just with something as simple as that, and then we will start customizing it. Okay, all right, so this is the histogram that we get. Okay, yeah, so it looks very plain, and let's make it a little bit more appealing in some sense. So the color that I like to use is still blue, and you don't have to use that, but at least that's what I like to use all the time. So then now, oops, yeah, we're customizing this a little bit. Let's add some edge color to these bars. Edge color equals to black. Okay. We can also add more, labels. So PLT title, long amount distribution, and we specify the font size, and then we see that the title now is here. Let's add X label. So the PLT X label, long amount. Okay, now we see the label here. Let's add a Y label. That will be for the frequency. And we can also add some grids. So we can do just grid like this. Excuse me. Right, but then yeah, let's keep only the horizontal ones. So then we can just do axis equals to Y. Let's add some transparency. So with alpha, that's the parameter. So 0.7, that's typically what I like to use. So okay, so that's our histogram. Again, it shows the distribution associated to long amount. So let's make this a little smaller. So and then let's use 5 here for the height. Okay, so we can see this here. All right. And again, so the histogram, what the histogram is telling us is how the numbers are distributed. Okay, so a couple of takeaways that you can get by looking at a histogram. Number one, you can more or less have an idea about the minimum, the maximum. More or less you can estimate where the numbers are centered, right? But more importantly, you can also look at how the numbers are distributed, right? So in statistics, anytime that you create a histogram and then you see that there is a tail, in this case, it's pointing to the right, so that is referred as a right skew distribution. Now, you may be wondering, okay, who cares? Why is that important? Well, from the statistical analysis standpoint, so that is information that you may use as a selection approach for potential distributions that you may consider to model that data. So, for example, exponential distributions, chi-square distributions, those are in nature right skew. So then when you see data and when you visualize your data with a histogram, and then if you are conducting a statistical analysis, just by identifying the distribution of your data, that will give you ideas in terms of a statistical distribution that you may want to consider to model your data. Okay, so that's basically, again, the takeaway insights in some sense that you get out of the histogram. You can see at the minimum value, more or less. You can see the maximum value. You can see where the numbers are centered, more or less. And more importantly, the distribution. Okay. And again, having a right skew distribution, again, some models, I mean, now talking from the machine learning perspective, some models are more sensitive when, the target, let's assume that this is the target variable, right? When the target variable has outliers, some models may be more sensitive towards outliers, meaning that it will be hard to predict those outlier values, okay? So that's why it's important to visualize your numerical data, okay? All right, so then this is, again, just the first option, right? Histogram is very popular, widely used. Another potential option is called a box plot, okay? A box plot is another graphical tool that you may want to consider to visualize your numerical data, okay? However, a box plot is basically a graphical representation of these 5 numbers that you see there. It's a graphical representation of the minimum, Q1, Q2, Q3, and the maximum, okay? So let's just create it, and then we will talk about the different features that you will find on the histogram. So let's start very similar. So I'm gonna be copying this command right here, or this line of code, and then after that is creating the box plot. So the command that you need to remember here is boxplot, okay? PLT boxplot, and then here we're gonna use long amount, let's just start with something simple. All right, so this is how the histogram looks like. Again, let's add a little bit of cosmetics. So the title, the white label, and the grid. So then that's very similar to what we did here. Okay, now let's rerun this. All right, now we add labels and the grid and so on. Okay, so this is the box plot. Again, it's a graphical representation of the 5-number summary. The minimum, again, what are the 5-number summaries? Is this one right here. Minimum, Q1, Q2, Q3, and the maximum. Okay, and the reason why it's called a box plot is because you see a box here in the middle. Okay, so this orange line that represents the median. Okay, in this case, these lines right here, right, that you see from the top of the box and then it ends here, similarly here from the bottom of the box and it ends here, those are called whiskers. Okay, if you're wondering how the whiskers are being calculated, so basically it's a two-step process. So first you will compute what is called the IQR, which stands for the interquartile range. So it's just you take the difference between this value, the top of the box, and the bottom of the box, and then basically once you have that difference, right, the value of that difference, you multiply that by 1.5, and then you just add that number to the top of the box, and then that will be the limit for your upper whisker in some sense. And for the bottom whisker, it's just once you have the IQR, multiply that by 1.5, and then you subtract that value from the bottom of the box. Okay. Now, if you're wondering what these dots are, so then one common rule of thumb when it comes to box plot is that data points that fall outside of the whiskers, so those are considered as outliers in your data. Okay, so and then and that's what we see here, right? There will be these points that we see here in the histogram. Okay, so these are the points that you see here in the box plot. Okay, another thing that you may want to be aware of is, again, the width of the box, right? The wider the box is, so then that also means that there is more variability in the middle of the data. Okay, that's also something to keep in mind. But that's basically all the takeaway messages from the box plot. So the orange line represents the median. The wider the box is, the more variability we have in the middle of the data. And then data points that they fall outside of the whiskers, so those are considered outliers in your data. Okay. And another common application of box plots typically is when you want to compare different groups of data, different groups of numerical data, but that will be the topic for another tutorial. So for now, we're using the box plot just to visualize one numerical variable at a time. Okay, so again, these are just two common options, or two common options that you may want to consider to visualize your numerical data. Either you consider the histogram or the box plots. Okay, well, that's all I have for this tutorial. See you on the next one.